Hello, welcome to the course of Engineering Chemistry. So in this unit we are discussing about alloys. So in the previous lecture we discussed what is an alloy, which is a homogeneous mixture of two or more elements and one among them should be a metal. So if one of the metal is present, then we can term it as an alloy. So alloys can be prepared for various reasons, and the reasons could be in order to improve the hardness or in order to vary the melting point, and if you want to change the color of an element, or it could be for improving the castability. And we discussed about the classification of alloys. So alloys are classified based on the content of iron present in that particular alloy. So if you have more of iron, then we can classify it as ferrous alloys. And if you don't have iron, or if you have very minimal quantity of iron, then such alloys are classified as non-ferrous alloys. So today we are going to discuss about what are ferrous alloys, which means the alloys which contain maximum or to a considerable quantity of iron element present in the alloy composition. So ferrous alloys are a classification of alloys based on the iron content. So these ferrous alloys will have maximum component as iron. So you have several compositions, and in one of the composition you have ferrous as the maximum content. So we discuss about three ferrous alloys today, and the first one is nichrome. As the name suggests, it has nickel, one of the element, and chromium, other element apart from iron metal. So nickel is 60 percentage and chromium is 12 percentage, and you have iron 26 percentage and manganese to a little extent of 2 percentage. So nichrome is an alloy which has nickel, chromium, ferrous and manganese. So in this you have 26 percentage of iron. That's why it is classified as ferrous alloys. So this alloy has several properties, and we look at few of them. So the first one is it has high chemical and heat resistance. The second one, it has high melting point, and the third one, it has high electrical resistance, and the fourth point, it has high oxidizability. So since it has high electrical resistance and high melting point, it is used for heating purpose. That's why it is used in heating coils, resistance coils, and it is also used in gas engines, aero engines, and valves. So when I say heating coils, it means that the material used in, for example, iron box, which we use for pressing, and then like dryer, could be like hair dryer, and it could be also used in water heaters. So nichrome, which is an alloy of nickel and chromium and contains 26% of iron, has a high melting point and high electrical resistance. So this is the reason we can use this as a resistance material, so that it will develop heat energy, which will be utilized for like drying purpose or for heating elements. The second alloy which we are going to discuss today is Alnico. As the name suggests, aluminum is one of the compound, which is the Al, and the Ni represents nickel and the CO represents cobalt. So the aluminum present here is about 12% and the nickel present here is about 20% and the cobalt is about 6%. So the rest is iron, which means if it is 12 plus 20 is 32 plus 6 is 38, so it's about like 60 to 62% of iron. So the main property of Alnico is it acts as a highly magnetic material. As we all know, magnetic property is mainly used for sound purpose. For example, it is used as permanent magnet in generators, motors, microphones, and telephone receivers, and etc. So Alnico is another type of ferrous alloy. So here the aluminum is 12% and nickel is 20%, cobalt is 6% and the rest is iron. So all this composition in a homogeneous mixture gives Alnico materials, which are mainly used for the magnetic purpose. So this magnetic purpose can be used for like making permanent magnets, which we use in generators and microphones, telephones, loudspeakers. There we use such Alnico materials. And the third type of ferrous alloy what we are going to discuss today is stainless steel. So in stainless steel we have the steel part. So steel first is an alloy. So the steel itself is an alloy, which is the main component is iron. So iron is the main component, and in order to increase its hardness we need to add carbon to it. So when we add carbon to iron, it will improve the hardness of that material, and this alloy is called steel. So steel is an alloy which has iron and carbon, and the carbon is added in few percentage just to improve the hardness of the iron metal. But this steel alloy is susceptible for corrosion. It cannot protect corrosion. So thus, even if it is added with carbon, this iron can corrode. So in order to decrease the corrosion of iron, we need to look for another alloy which is a derivative of steel called stainless steel, which has, apart from carbon to iron, it also has nickel and chromium. So when we add nickel and chromium to steel, it will be corrosion resistance. So this will protect the iron metal from corrosion. So how it protects is due to the presence of chromium. So this chromium, when oxidizes, it becomes chromium oxide. So this chromium oxide, it forms a dense and tough film. So this dense and tough film protects the iron from corrosion. That's why stainless steel acts as a corrosion resistant material compared to the steel. So we have several stainless steel compounds, and we are going to look one by one. So the first one is metallic stainless steel. It can also be called as heat treatable stainless steel. So metallic stainless steel is a kind of stainless steel which can also be called as heat treatable stainless steel. It possesses chromium 12 to 14% and it has carbon of 0.12 to 0.35%. So this has a property of easily machined. So you can make machines easily out of this stainless steel, and the name metallic stainless steel comes from the structure metallic. So it possesses this structure, that's why the structure name turns to be the name of the stainless steel. And where we use such stainless steel is in hydraulic steam and mainly in surgical instruments. So the instruments what we use in surgeries, and apart from that, scissors, blades and cutlery are all made of this metallic stainless steel. The second type of stainless steel what we are going to discuss is ferritic. So ferritic is a kind of stainless steel and it is also called as magnetic type steel. So the second type is ferritic stainless steel and it's also called as magnetic type steel. So it possesses about 0.12% of carbon and few percentage of chromium and nickel apart from the iron. And its main property is it is better corrosion resistance and it has good ductility, and this is also easily machinable as like the metallic stainless steel. The main uses of this ferritic type stainless steel in pump shafts and spindles and valves. So these are all the places where we use this type of stainless ferritic steel. The third type is austenitic. Austenitic stainless steel. So this is the third type of stainless steel, and this is also called as non-magnetic type. So in this particular stainless steel, you have high percentage of chromium and nickel. So the percentage is about 18 percentage chromium and 8 percentage you have nickel. So that's why this type of austenitic stainless steel are also called as 18 bar 8 type steel, because it possesses 18 percentage of chromium and 8 percentage of nickel. So this type of stainless steel are corrosion resistance, and they are also chemical resistance. So because of their corrosion resistance and chemical resistance property, this type of stainless steel is mainly used in household utensils, because the food item what we keep can be acidic or basic. It should not be affected the material. So if it affects the material, it will dissolve into the food material. That's why it is used in household utensils, where it will not be chemically attacking, or it will not corrode the iron present in that steel. So it's used in household utensils, and then it is also used in the sinks in our home as well as in the chemistry labs. And then it is used in dental, and sometimes it's also used in surgical instruments. The fourth type is tool steels. As the name indicates, it is good in making tools because of their high strength, hardness, and importantly resistance to wear and softening. This is used in making tools like hammers, shears, drill, and dies, then like drawing wires, etc. So these are all the four type of stainless steels which we use in day-to-day life for several different properties. So the first one is merton stick stainless steel, which is also called as heat treatable stainless steel, which is easily machinable, and then it is used in mainly in surgical instruments which need to be corrosion resistant so that it will not infect the person. And the second type is ferritic stainless steel, which is also a good corrosion resistant stainless steel, and it has good ductility, and this is also easily machinable. It is used in making spindles, valves, and then shafts. The third type is austenitic stainless steel, which has about high percentage of chromium and nickel to an extent of 18% chromium and 8% of nickel. So this is otherwise called as 18 by 8 steel. It has a very good corrosion resistance and chemical resistance. That's why it is used in household utensils and in making sinks, and then for dental reasons as well as for surgical instruments. The fourth type is tool steel, which is mainly used for making tools because of their hardness and high strength. So the materials which can be made out of it is hammers, shears, and then for drawing wires and making dies. So in today's lecture we discussed about what is ferrous alloy, which is the alloy which has the main component as ferrous or to a maximum quantity of ferrous in that composition. And we discussed about three different ferrous alloys starting from nichrome, and in nichrome we have nickel and chromium apart from iron. So its main property is it has a high electrical resistance and a high melting point, and because of this reason it is good in making heating coils, and the corresponding application is it can be used in iron box, it can be used in water heaters and in hair dryers, where we convert the electrical energy into heat energy for drying purpose or for heating purpose. And apart from that, we discussed about Alnico, which is another kind of ferrous alloy in which it contains aluminum, nickel and cobalt. So this is a very good alloy because of its magnetic property, and this is widely used for its magnetic property in making generators and in making motors, microphones, telephone receivers, and for like speakers, loudspeakers. Wherever you use permanent magnet, it is mostly made up of Alnico. And the third important type, we have stainless steel, which is the most used alloy, and we use it in the day-to-day life because of its non-corroding nature. And this alloy is an alloy of steel, which is again an alloy of ferrous and carbon. So the carbon is added to iron in order to improve the hardness, and the material produced is called steel. When the steel it combines with nickel and chromium, it imparts the corrosion resistance property, and as a result this steel is corrosion free, or we can say the iron is corrosion free. And it has 3 or 4 different types. In each type has its own significance based on the content of the composition present in each compounds. And in today's lecture we discussed about the ferrous alloys and few examples of ferrous alloys, and in the next lecture we are going to discuss about non-ferrous alloys and semiconductor alloys. Thank you.